in the ratio of 1 for x, 3 for x2. Based on this, you are to add 1 to 3, making it 4, and the fraction of x is 1 over 4. 1 plus 3 make up for the 4. So the ratio of x1 to the total will be 1 over 4. For the x2, the ratio of x2 is 3. To the total, it will be 3 over 4. Taking it to the percentage, multiply by 100%. Then you will have 25% for x1. Multiply by 100%, then you have 75% for x2. And since the question asks us to look for the relative atomic mass of x, the relative atomic mass of x, denoted by RAM, is the same as saying the percentage of this x1 multiply by the relative atomic number of x, 20, plus the percentage of x2 multiply by the relative atomic mass of x2, which is 22. Furthermore, the percentage of x1 from above is 25%. Multiply by the relative atomic mass, which is 20, plus percentage of x2 from the above is 75%, times the relative atomic mass of x2, which is 22. By simple arithmetic, this can be, this is 5, this 25 year 1, 25 in 104. 25 in 104. 4 year 1, 4 in 25. So that is what accounts for the 5 that you have here. Plus 25 year 3, 25 year 4, 2 year 2, 2 in 22, 11. This 3 times 11, that gives 33 divided by 2. So that will be 2 in this, 1, remainder 1, making up for 13. 2 in 13, 6, remainder 1. 2 in 1, 0.5. That accounts for 16.5. So when you sum this together, it will be equivalent to 21.5. That is the relative atomic mass of these elements X. The answer to question 1 is 21.5. Back to question 2. The elements here is of the same respect, X. It exists in 2 forms, which are x1 and x2. The fraction of x1 is 1 over the total, which is 3, times 100 over 1. This one is the ratio of x1 from the question, while 3 commensurate for 1 plus 2, making it 3. So the fraction is 1 over 3, and taking it to percentage is times 100 over 1. And this gives us 33.33% for x1. For x2, the ratio of x2 in the question is 2. Then the fraction of x2 becomes 2, which is the ratio of x2 all over the total, 3. And taking it to percentage, it becomes 100 over 1. And this gives us 66.67%. Now, to calculate the relative atomic mass of X, will automatically be the percentage of your X1, times the mass of X1 plus percentage of X2 times the mass of X2. Percentage of X1 is 33.33%, which is 33.33 over 100, times the mass number of X. The mass number of X from the question is 18, plus the percentage of X2, which is 66.67 over 100, times the mass number of X2 from the question, it is 20. This one gives 5.93. This multiplied by this divided by 100 gives 5.93, plus this multiplied by 20 divided by 100 gives 13.33. Approximately, this gives 6 plus 13.33, which is equal to 19.33. And 19.33 is the answer to question 2. The answer to question 2 is 19.33. Question 3. The positively charged particles in an atom are A. Protons, B. Electrons, C. Neutrons, D. Nucleus. Based on the last topic, I was able to establish that in the nucleus, you have this is the nucleus. Inside of this nucleus, you have the protons, which is positively charged. Inside the same nucleus, you also have neutrons, which is 0 charge. And outside, you have the electron, which is negatively charged. Based on the question 3, the positively charged particles in an atom is what? Automatically, the only positively charged particles here is the protons, which is the answer to the question 3. That is A, protons. Symbols, formulae, and equations. The chemical symbols of the first 20 elements and their valencies are listed below. Tables of the first 20 elements: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Formulae. There are 2 molecular and empirical formula. Empirical formula, it is the simplest formula that represents the number of atoms present in one molecule of a compound. From the words you are to pick the simplest and the mole of a compound. Empirical formula is the simplest